Assalamu alaikum and welcome to Mathcast with Faria Yusuf. This video is about trigonometry and it's going to be the introduction on trigonometry where we will be covering some basic concepts of trigonometry. So the first thing that we should be knowing here is that if a right triangle is given to us, if it's and here in this triangle, if we have this angle at A, which is an x, then with respect to this x, we can see that the side which is adjacent to the x is called the base and the adjacent, and the side opposite to the angle x can be given as a perpendicular or an opposite, and the side which is opposite to 90 degrees is called the hypotenuse here. So with respect to the three sides, which is base or adjacent and perpendicular or opposite and the hypotenuse, we should be having three trigonometric ratios, and the three trigonometric ratios are sine theta, which is equals to perpendicular over the hypotenuse, or we can say it's the opposite over the hypotenuse. The second is the cosine theta, and for the cosine theta, we say that it's the cosine, or we can write it as a cos theta, and for this cos theta, we can say it's the base over the hypotenuse, or we can say that it is the adjacent over the hypotenuse. So after the two basic trigonometric ratios, the sine theta and the cosine theta, we have the tangent theta, or simply we can call it the tan theta. And this tan theta is basically the ratio of sine theta over cos theta. The tan theta is basically the ratio of sine theta over cos theta, or we can say if it is the sine theta which is opposite over hypotenuse and the cosine theta which is adjacent over the hypotenuse, then we can say that tan theta is actually the ratio of opposite over adjacent here. Opposite over adjacent, or we can call it the perpendicular over the base. So these are the three important trigonometric ratios. It's the sine theta, the cosine theta, and then we have the tangent theta. These are the three basic, very important trigonometric ratios that we should be knowing to start the chapter of trigonometry. In order to remember the three trigonometric ratios, we can also say that sine, cosine, and tangent, for the purpose of remembering the three ratios, we can call them as a SOHCAHTOA, SOHCAHTOA, meaning we can have this as sine opposite over hypotenuse, sine opposite over hypotenuse. Then we can have cosine, which is for adjacent over hypotenuse, and then we have the tangent, which is opposite over adjacent. So this is how we can remember the three trigonometric ratios in a right angle triangle, which is SOHCAHTOA. So meaning sine opposite over hypotenuse, ka cosine ratio, which is adjacent over hypotenuse, and then toa, meaning tangent, which is opposite over hypotenuse. So these are the three very important trigonometric ratios for a right angle triangle, which all the students should be knowing to do trigonometry. After that, it's the Pythagoras theorem, and for the Pythagoras theorem, we know that Pythagoras theorem is given as a hypotenuse the whole square, which is equals to perpendicular square plus base the whole square. So this is our Pythagoras theorem, or we can say that this is h square, which is equals to p square plus b square. So this is another thing that we all should be knowing to do trigonometry. Exact values of trigonometric functions. So to get the exact values of trigonometric functions, we should be taking help of a unit circle. Unit circle means that the radius for this circle is going to be a 1. It shall be a 1. The radius in this circle, the radius here, it shall be equal to a 1. meaning I can see O up till the circumference on the x-axis. This is also going to be a positive 1. O up till the circumference on the other side. It's a 1 unit here. Starting from the origin, I can write it as a negative 1. O up till the positive y-axis. Again, the radius is a 1, so I've written a 1 here. And then O up till the negative y-axis, obviously it's going to be a negative 1, giving us the radius which shall be equal to a 1 here. So if we have a point P here on the circle having coordinates x and y and the radius 1, I can drop a perpendicular up till the x-axis so that I can see that OQP is a perpendicular here. So to get the x and the y coordinate of this point P on the circle, I can use the trigonometric ratios. And using the trigonometric ratios, first it's going to be the sine theta here. And this sine theta we know is opposite over opposite over hypotenuse, and opposite in this case is a PQ, and hypotenuse in this case is an OP, which actually is the radius here. So PQ is what we are supposed to find out. OP is the radius 1, and I can see here that PQ, which is actually the y coordinate for this point P, is going to be equal to a 1 into sine theta. So I can say that this is just going to be a sine theta. So here I can say that the y coordinate of this circle is going to be a sine of this point P on the circle is going to be a sine theta. In the same manner, I can take help of cos of theta, and this cos of theta we know is the ratio of adjacent over hypotenuse. Our adjacent in this case is OQ, and hypotenuse is the radius, which is OP, and I can say that this OQ that this is going to be OQ divided by OP, which is the radius, and that is a 1. Therefore, I can see here that x coordinate of point P is going to be OQ, and this is then going to be a cosine theta. So OQ then is going to be a cos theta here. So for a point P on the circle, the x coordinate is given as r cos theta. For any other circle with any other radius, we can say that the x coordinate of a point on a circle is then going to be r sine theta. R can have any value. It's going to be r cos theta. And the y coordinate of a point on the circle is r sine theta. R again can have any value, meaning any point on the circumference of the circle, coordinates x and y shall be given as r cos theta and r sine theta. So this is how we can find the coordinates of a point on the circle with respect to the quadrant in which it lies, meaning if it lies in the second quadrant here, 90 to 180 degrees, then we can see that the x coordinate here is going to be a negative because of the negative x-axis, and the y-coordinate then is going to be a positive. Meaning if I just redraw the diagram here, then I can say that for this diagram, if it's in the second quadrant, then with respect to any point in the second quadrant, I can see that the x-coordinate here is going to be a minus r cos theta, and the y-coordinate being on the positive y-axis is just going to be a positive r sine theta. Let's call this point an A. If it's in the third quadrant, then with respect to the third quadrant, so with respect to a point in the third quadrant, let's say that it is point B, I can now say that the x coordinate here is going to be a negative r cos theta because of the negative x-axis, and for the y coordinate, I shall be writing it as a negative r sine theta. Negative r sine theta, because again I can see that it lies on the y-axis, which should be having a negative coordinate here. And then in the same quadrant, in the fourth quadrant, I should be saying that if it is in the fourth quadrant, then to be in the fourth quadrant, then I should say that the coordinate here shall be, I can see that the x coordinate shall be a positive because of the positive x-axis here. Y coordinate shall be a negative because of this line, this perpendicular, which is towards the negative x-axis. Therefore, here again I can say that it's going to be, the x coordinate here is going to be r cos theta, and the y coordinate here is going to be a negative r sine theta. So this is how we can give the coordinates of a point P on the circle with respect to the quadrant in which it lies here. So after that, let's go to some exact values of trigonometric functions. Without using a calculator, for cos of 0 degrees, or cos of 0 radians, I should say that it's going to be the value which is just going to be a 1 here. Cos of 0 degrees, it's just going to be a 1, because we can see that if we just look at the angle towards the x-axis, if we look at this value towards the x-axis, then I can see here that for this x-axis, here, it's the x-axis representing the cosine, and it's the unit circle here with respect to the radius, which is a 1, the radius here from O to, let's call the other point as A. So with respect to OA, I can see that the radius is a 1, therefore the cos of 0 degrees, here shall be equal to, or 0 radians here shall be equal to a 1 then. In this, cos of 0 is a 1. What about sine of 0? Sine of 0 then is going to give us a 0 value, because I can see that sine of 0, sine is basically the y coordinate of the point P which lies on the circle. We are talking about 0 degrees, which means we are talking about OA also. So with respect to OA, obviously the sine of 0, it has to have a 0 value, because A is just for x and a 0 here. It's lying on the x-axis. Therefore, I can say A has the coordinate which is x comma 0. And then from here, I can say it's tan of 0 degrees, which is actually the ratio of sine of 0 to cos of 0. So that is going to be 0 divided by 1, and this shall give me the answer which is a 0. So I have all the three ratios for sine, 0 degrees or 0 radian, sine of 0, sine, let's call it as theta, sine of 0, that is equal to a 0, cos of 0, that is equal to a 1, and then tan of 0 is actually the ratio for sine over cos, giving us a 0 value. So this is how I can get the angles representing 0 degrees or 0 radians here. Now with respect to the same triangle, as for the same circle, let's go for 90 degrees, or a pi by 2. So we know that 90 degrees, it lies over here. 90 degrees angle, it's anti-clockwise. So this will be giving us a 90-degree rotation. This is giving us a 90 degrees rotation here. So with respect to this 90 degrees rotation, what I can see here is that with respect to this 90 degrees, again, if I have the point B on the circumference of the circle lying on the y-axis, then this, for this point B, the x coordinate is a 0, and then there should be a y coordinate here. We have already decided that for a point on the circle, the y coordinate is given as a sine theta. Therefore, with the radius as 1, we are also doing it with respect to the unit circle. Therefore, with the radius as 1, radius here from O to B, that is the radius, which shall be equal to a 1 unit. So I can say that for this point B, let's call it OB, or 90 degrees. So for 90 degrees represented by OB, the radius is a 1. So in this case, the radius is a 1, and B having the x coordinate as 0. Therefore, I can say it's cos of 90 degrees here, which should be equal to a 0. Sine of 90 degrees here, this should be representing a 1, and then tan of 0, tan of 90 degrees, again a ratio for sine 90 divided by cos of 90. So sine of 90 is a 1, but cos of 90 is a 0. And we know that if we divide any number by 0, then that number is going to be undefined, or it's going to be an infinity, meaning tan of 90 shall be an infinity over here. In the same manner, let's go for 180 degrees and then 360 degrees. So let's solve for 180 degrees. So solving for 180 degrees, 180 degrees, which now we can say is OC, 180 degrees, which is representing OC, and again we can say that the radius here is a 1. At B, it's going to be 180 degrees. So C point at 180 degrees shall be having a negative x coordinate because of the negative x axis, and then the y coordinate has to be a 0. So again, we know that the radius here from O to C, this is going to be a 1 unit. The radius here is going to be a 1 unit here. So with respect to this 1 unit, our cosine value here, cos of 180 degrees, shall be equal to a negative 1 because of the negative x-axis. So it's cos of 180 degrees, which shall be equal to a negative 1, and sine of 180 degrees, which shall be equal to a 0, because it's the point C here, which shall be represented by, we are talking about the point C, which shall be represented by the negative x coordinate and the y coordinate to be a 0. Y coordinate is a sine theta. So here it's sine of 180 degrees, which should be equal to a 1, and cosine of 180 degrees then should be equal to a negative 1 here. And tan theta then, tan 180 degrees being the ratio of sine 180 divided by cosine 180, that should be equal to 0 divided by 1, and I can say that tan 180 degrees shall be equal to a 1 here. So here again we are having all the three trigonometric ratios, cos, sine and tangent, to be equal to a negative 1, a 0, and then tan of 180 degrees to be equal to a 1 here. Let's move to 270 degrees. So with respect to 270 degrees, now let's call this point a D. So with respect to 270 degrees, let's call this point a D, and what I can see here is that the x coordinate is 0 and the y coordinate has to be a negative y because of the negative x axis. So 270 degrees represented by OD, and the radius obviously is a 1. So with respect to all these values that we have, 270 degrees, OD and the radius as 1, now I can say very easily that cos of 270 degrees being the x coordinate, that should be equal to a 0. Sine of 270 degrees being the y coordinate, it should be equal to a negative y. And here I can see that O till D again is the radius, and towards the negative y-axis it has to be a negative 1. Therefore, I can say that sine of 270 degrees needs to be a negative 1 here. And then for tangent 270 degrees, that should be equal to sine of 270 divided by cos of 270 degrees. Sine of 270 degrees is a negative 1, cosine is a 0. Any number divided by 0 is going to be undefined. Therefore, I can say tan of 270 degrees is going to be infinity, or it's going to be undefined. So meaning at tan of 270 and tan of 90, that should be an asymptotic line that we should be having here on the graph, which we shall be doing in the later videos. So this is how we shall be giving the trigonometric ratios to the axes angles after 270 degrees for 360 degrees. That means we are taking a complete rotation here. And one thing we should be noting here, that all the angles, they are being taken anti-clockwise. We are just having all the angles moving in the anti-clockwise direction. So this anti-clockwise direction here is taken as a positive rotation. So for 360 degrees, I can see that for 360 degrees, starting from 0, then 90, and then 180, and then it's a 270, and then finally 360 degrees there. It's a 270 degrees here. This is a 0 and a 360 degrees, and at B we were having a 90 degrees rotation here. So for all these values here, what we have seen here is that all the angles are taken in the anti-clockwise direction. We have moved starting from 0 in the anti-clockwise direction, and these angles in the anti-clockwise directions, they are taken as positive angles, positive values for trigonometric ratios. Now for 360 degrees, we can see that it's 0 degree, 0 radian, 360 degrees, or a 2 pi radian. So for all these values here, I can also write these angles in radians, and I can say that 360 degrees is a 2 pi radian, 90 degrees is a pi by 2 radian, 180 degrees can be given as a pi radian, 270 degrees then is given as a 3 pi by 2 radian value here. So for all these angles here, when starting for 360 degrees, we can see that 360 degrees is the same as point A. Therefore, all the values for 0 degrees or 360 degrees, they are going to be equal. Therefore, we can say it's cos of 360 degrees, which equals cos of 0, that equals a 1. Sine of 360 degrees will be equal to sine of 0, and that shall be equal to a 0. And tan of 360 is equals to tan of 0, that is also going to be a 0 value here. So consolidating all the axes angles, for 0 degrees, 90 degrees, 180, 270, 360 degrees, sine of theta is a 0, 1, 0, -1, and a 0, and these are the angles for all the cosine axes values here. So I have just consolidated all the axes angle values in the table format for all the three trigonometric ratios: sine theta, cosine theta, and tangent theta. So after the axes angles 0, 90, 180, 270, and 360 degrees, there are few more angles for which we should be knowing all the three trigonometric values. And to do that, let's have this equilateral triangle ABC. Equilateral triangle meaning it has to be having the three angles which are going to be 60 degrees, and then all of them, they are here having the side length which is a 2 unit. So 60 degrees here, we know that sine, cosine, and tangent, they are all for right angle triangles. So if I just drop this perpendicular here, a to x, I can see that this x point has to be the midpoint of BC. Therefore, the length of BX shall be equal to a 1. And then if I'm dropping this perpendicular, then this 60 shall be divided by 2, giving me this angle value here as 30 degrees. So I will be using half of the triangle here, like I have this triangle A, X, and B. So that at B we are having 60 degrees, at A we shall be having a 30 degrees. X is a perpendicular, and this side length is going to be a 1, BX, and then AB was equal to a 2. So with respect to the hypotenuse and 1, applying the Pythagoras theorem, I can say that this perpendicular here then shall be equal to under root h square minus b square, or perpendicular shall be equal to under root 2 square minus 1 the whole square, or p shall be equal to 4 minus 1, giving me under root 3. So I have this perpendicular as under root 3, I have this hypotenuse as a 2, and I have this adjacent as equal to a 1 here. So with respect to this 60 degrees or pi by 3, I should be able to get all the three trigonometric values. Therefore, 60 degrees, which is equal to pi by 3 radian, I can say it's cosine 60 or cosine pi by 3. That should be equal to adjacent over the hypotenuse. That means it's bx over ab. And I can see that this value here is the ratio of 1 over 2, meaning cos of 60 or cos of pi by 3 radian, that should be equal to a 1 by 2. And then sine of 60. Sine of 60 degrees, it has to be perpendicular over adjacent, or I can say it is, perpendicular over hypotenuse. Therefore, I can say that it has to be ax divided by ab, which shall be equal to under root 3 by 2 here. So sine of 60 here comes out to be under root 3 by 2, or sine of pi by 3 we can say is an under root 3 by 2. Having tan of 60, tan of 60 or tan of pi by 3, we can say that it is perpendicular over adjacent, which shall be equal to ax over bx, that is equals to under root 3 by 1, and we can say tan of 60 or tan of pi by 3, that shall be equal to an under root 3. Meaning now I can say I have the sine, cosine and tangent values for 60 degrees or pi by 3 radians, and these values are a pi under root 3 by 2, 1 by 2, and then tan 60 degrees is equals to under root 3. Now, with respect to the same triangle, I can also have the angle values for 30 degrees. I can have sine of 30 degrees or sine of pi by 6, cosine, and then tangent also. So let's solve for 30 degrees also. So 30 degrees equals a pi by 6 radian, and for 30 degrees equal to a pi by 6 radian here, I should say that for 30 degrees which or a pi by 6 radian, I should say that it is cos of 30 degrees here. With respect to 30 degrees, obviously this is going to be my adjacent, bx is going to be my opposite, and my hypotenuse is going to be a 2. Therefore, cos of 30 degrees then shall be equal to adjacent, which is under root 3 divided by 2. Therefore, cos of 30 is under root 3 by 2. Sine of 30 shall be equal to bx, opposite, over hypotenuse, which is AB. So that can be equal to a 1 by 2 here. Tan of 30 degrees or tan of pi by 6 shall be equal to opposite over adjacent, and opposite over adjacent means that it has to be bx divided by ax, which shall be equal to a 1 upon under root 3. So compiling the sine, cosine and tangent values for 30 degrees or a pi by 6, we can say sine of 30 is a 1 by 2, cos of 30 or a pi by 6 is an under root 3 by 2, and tan shall be equal to 1 over under root 3 here. After that, we can have an isosceles triangle, and for this from this isosceles triangle, I shall be finding out the angle values for 45 degrees here. So for an isosceles triangle, a right isosceles triangle with the two angles as 45 degrees, I can say that this side length is a 1 and the other also is a 1, and with respect to that I can have the hypotenuse, so that the hypotenuse becomes under root 1 plus 1, and I can see here that hypotenuse is equals to under root 2 here. So I have, with respect to this 45, I have this adjacent, this is my perpendicular or the opposite, and this then is going to be the hypotenuse. Therefore, sine of 45 degrees is opposite over hypotenuse, sine of 45 opposite over hypotenuse 1 over under root 2. Even if I would have gone for this 45 degrees, I would have gotten the same ratio 1 over under root 2, because with respect to this 45, this is my opposite and this is my hypotenuse, which is again giving me 1 over under root 2. So cos of 45 degrees then shall be equal to 1, which is the adjacent, and under root 2, which is my hypotenuse. Tan of 45 or a tan pi by 4, this can be a sine pi by 4 divided by cos pi by 4, or we can say that it is opposite over adjacent. So 1 over 1, that is giving me the 1 as my answer. So for 45 degrees and pi by 4 radian, again I have all the three trigonometric values. Sine is 1 over under root 2, can also be written as under root 2 by 2. Or I can say cosine is also under root 2 by 2 or a 1 over under root 2, and tan here then becomes a 1. When you feed 45 degrees for sine and cosine in your calculator, you will see that the angle values that you will be getting in the calculator is under root 2 by 2, which is the same as 1 over under root 2 here. So consolidating all the angles that we have found up till now, 0, 60, 0, 30, 360, 45, 90, 180, 270 and 360, all the axes angles, and then 30, 60 and 45, or in the radian mode it's 0, pi by 6, pi by 3, pi by 4, pi by 2, pi, 3 pi by 2 and 2 pi. We can have all the sine values and the cosine values and the tan values. And here I would advise my students to learn these values by heart, because then these values here, they will be highly useful if you have them on your fingertips to solve your trigonometric equations or your trigonometric graphs for sine, cosine and tangent, which we shall be doing in the later videos. Now, from this table that we have, we will be coming to the complementary angle property. So what is the what do we mean by the complementary angle? So complementary angle here, if I look at 30 and 60, 30 plus 60 is actually 45, is actually a 90 degrees, or pi by 6 plus pi by 3 is actually a pi by 2 radian. So what we notice here is that I can have this, what I can see here is that sine of 30 is a 1 by 2 and cos of 60 here is also a 1 by 2, meaning the two complementary angles for sine and cosine, the two complementary angles here, they are having the same value. I can see the vice versa also. Cos of 30 is the same as sine of 60. Again, complementary values. And also, what I can notice here is that for 45 degrees, the complementary angle is a 45. Therefore, sine of 45 and cos of 45, they are also giving us the same values, which is 1 over under root 2 or under root 2 divided by 2 here. 0 and 90, they are also complementary angles. So sine of 0 is a 0, and we can see that cosine 90 is also a 0. Sine of 90 is a 1, so complementary. Cosine of 0, that is also giving us a 1 here. So from here, I can have this complementary angle property for sine and cosine values, where I can say that it's sine of theta, which shall be equal to cos of 90 minus theta, or in the radian mode, it's cos pi by 2 minus 30, minus theta degrees here, radian here. Or I can say that for cosine theta, that should be equal to sine of 90 minus theta, or it should be equal to sine of pi by 2 minus theta. So just giving you an example other than 30 and 60. So what I can see here is that if I have given you sine of, let's say it's 20 degrees, then this sine of 20 should be equal to the complementary angle for cosine, meaning it should be equal to 90 minus 20. So that means sine of 20 and cosine of 70, both of them, they shall be giving us the same angle values here. And this angle value then is going to be 0.342. So I can see that sine of 20 and cos of 70, both of them, they are giving us the same value, which is a 0.342 here. Or if you go for cos of 50 degrees, then cos of 50 degrees should be equal to sine of 90 minus 50 degrees, which shall be equal to 40 degrees here. So cos of 50 or sine of 40, cos of degree or sine of 40, both of them again shall be giving us the same angle value, which is a 0.643. So this is a very important property, which is the complementary angle property for sine and cosine. Now, if we look at the tangent function for the complementary angles, there is a property for that also, for the tangent for the tangent angles also, and this is that if I have tan of 30, then the complementary angle for 30 is a 60. Tan of 60 is actually the reciprocal of each other. Tan of 30 is a 1 over under root 3 and tan of 60 is just a 3. Tan of 45, again that's a 1, so tan of 45, that has to be a 1 only. 0 and 90. 0 and 90, 0 and 90 degrees here, they are giving us tangent 0 as a 0 and tangent 90 as undefined or infinity. So again I can see that 0 and infinity, they are the inverses or the reciprocals of each other. So for tan of theta, I can have the complementary angle identity, and this identity then shall be tan of theta shall be equal to 1 over tan of 90 minus theta degrees. So here I can say if I have tan of 20 degrees, then it should be equal to inverse of 1 over tan of 90 minus 20. So tan of 20 shall be equal to the inverse of tan of 70 degrees here, and this value for both then shall be equal to 0.364. So this is the complementary angle identity for the tangent ratio. So from here we should be deducing the complementary angle property, which says that its complementary angle property, which is sine theta, equals cos of 90 minus theta, or cos theta equals sine of 90 minus theta, or tan theta equals 1 over tan 90 minus theta here. So after doing the complementary angle identity, we shall be having another identity here, which shall be called as a supplementary angle identity. And for supplementary